Ahoy, you scurvy sea dogs! Why am I talking like a pirate? Because the pirates depended upon the subject that we're going to be talking about here for the next little while. And that would be ocean currents. A current is a body of moving water or moving air. Specifically, a surface current is like a river of moving water that's actually traveling through the ocean. Surface currents are very, very important to the sailors of the old days, where they had to use sails because the currents would actually help move their ships along. And even today with modern ships which have powerful engines, if the current is pushing with the ship can use less fuel and can go faster. So currents are very important. Not only are currents important to sailing ships and vessels moving across the ocean, you're going to find out as we study more how incredibly important they are to the weather. They really have a tremendous effect on the weather. So let's learn exactly what causes a surface current. Okay, if you'll notice right here on the map, right down the middle, I've got some black dots. This represents the equator. The equator, as we all know, the equator is the middle of the Earth. It is the warmest place on the whole planet. So the water in these areas around here is going to be very hot. This is going to be the hottest ocean water, all up and down around the equator. All right. Now, also, we have something called global winds. Global winds. So these global winds, because of the Earth's rotation, there is a global wind north of the equator, just north of the equator. This is called a trade wind. Okay, as you can see, there's a trade wind here, and there's a trade wind just south of the equator. So we got two trade winds, one north of the equator and one south of the equator. All right. Now it's important to realize and remember that the equator is 0-degree latitude. 0-degree latitude. And latitude tells us how far away from the equator we are. The higher the number of the latitude, the colder it is. The lower the number of the latitude, of course, the warmer it's going to be. And so I bring that up at this point because there is another set of global winds called the Westerlies. The Westerlies travel at 40-degree north latitude and at 40-degree south latitude. So these between the trade winds and the Westerlies, they have an awful lot of impact on making ocean currents move, about getting this ocean water to going. So I'm going to go and change maps here, and we're going to look at how these global winds can push this water along. Now these winds that we're looking at here, the trade winds and the westerlies, as they're blowing across the ocean, they set the water to moving. They set the water to moving. So north of the equator, I mean, here's good old Florida, Georgia, here's our coastline right here. And we have something called the Gulf Stream. And the Gulf Stream is a very, very warm water that's off the coast of the United States. So let's see how these winds affect that current. So we got the trade winds, as they're pushing across the ocean, all this warm water down here is being pushed in this direction. Now, the winds are blowing in a circular direction. They blow pretty much in a straight line, just like we're looking right here. But yet, when that water gets here, there's a continent in the way. And so obviously the water can't go across this continent, so it kind of bounces off of it and starts going up this direction. And then it hits the coast of Georgia and Florida and kind of can't go through there, so it bounces off again. And then as it's being pushed, so now the trade winds are pushing this water up in this direction. Then as it gets up north far enough, the westerlies start pushing that water back across the ocean. So now, as you can see, we've got a change in direction. And as the westerlies are pushing that water, some of it comes over in this area, and it gets split and kind of gets pushed up this way now. Remember, this is coming from the equator. So this is very, very, very warm water. So as this warm water is pushed across the ocean, we've got a warm water current that's coming up over here to Great Britain and Northern Europe and actually warming them up some. It's kind of like a heater system. It helps them be warmer. But as that Gulf Stream is pushed across the ocean, the name changes to become the North Atlantic Current. So that North Atlantic Current, part of it goes up this direction, carrying warm water up around Iceland and up off the coast of Norway, and some of it kind of hits this continent and gets ricocheted back down this way. Well, this is a colder area, so this water is cooled off, it's given up a lot of its heat, and now that cool water starts coming down along the coast of Africa. So we got warm water going up and cool water coming back down. Okay, I want to step back and recap about these winds again for a few minutes, because I think it's very, very important that we understand that surface currents are caused by the wind. Ocean surface currents are caused by the wind. And we said we've got at 40° north latitude, we got these winds called the westerlies. We had these winds called the westerlies at 40 north and at 40 south, and they're always moving in this direction, always. Then just north of the equator, blowing from the east, we have the trade winds. The trade winds are never ending, they're always blowing, and they're always blowing just north of the equator and just south of the equator. Now, the perpetual blowing of these winds, the winds pushing this direction, sets this water in motion. It sets this water in motion. So I'm going to use some different colors here. All right, we're going to use red for warm. So we got warm water coming up across the equator, bouncing off to South America, coming up here and bouncing off the east coast. And then when it gets up over here, it's still kind of warm water. But then we have some ricochet, and that cold water starts getting cooler, and so it brings cool water along the coast of Africa, which is a very good thing, because Africa being so hot, with the Sahara Desert out here, it would be very difficult. But this is where most of the population of these countries lives. Most of the people living in these countries live along the coast of Africa, because this cooler water coming down makes the climate a lot nicer. Okay? If you look at this, you'll see, and I'm changing to a yellow color here, this is a circular motion. This water is constantly moving pretty much in a circular direction, and when there's a special name for this, it's called a gyre. A gyre. We have a gyre out here. We have a gyre here. We got the gyre moves in the opposite direction. There's a gyre over here. We have a gyre over here. We have a gyre right here. Okay. We have a gyre here, and we have one here. There's another gyre. And there's one in the Indian Ocean too. Let's see, I think it goes like this. Okay, so these gyres move in this direction. And as you can tell by the way these gyres are shaped, this circulating this ocean water always from the equator, okay, from the equator, because the trade winds are blowing in this direction, they're going to push the water like this, okay, they're pushing the water like this, it goes down and comes up. So along the coast of South America, we've got cold water being brought up. Along the west coast of the United States, we've got cold water being brought down. So if you've ever looked at movies about California, they've got beautiful beaches out there, and you got people riding bicycles and flying kites and laying out on the beach, but they're never swimming because that water is so cold because it's coming down from Alaska. So the west coast of most countries are getting cold water brought down from the northern reaches or brought up from the southern reaches like South America. So these gyres, now there's two things that affect these gyres. The first thing that we've already talked about would be these global winds. The global winds are westerlies and our trade winds. But there's another important feature going on too, and that's the Coriolis Effect. The Coriolis Effect. And if you look at that word, and you've already written it down in your notes, Coriolis, I see the word coil, and coil means to circle, okay? So the Earth's rotation also helps to make these waters spin. So you got the winds pushing it this way and this way, but then the Earth's rotation gives it a twist. So the Coriolis Effect, the winds and the Coriolis Effect is what helps produce gyres. It's what helps make these surface currents move across the surface of the Earth. So let's do a little recapping now, but I'm going to add another term in here while I'm doing it as I go along. So see if you can catch what I'm going to tell you about now. All right, so remember, we got the equator runs right across here. We got the equator, 0-degree latitude, and then just north and south, just north of the equator and just south of the equator, we have the what? The trade winds, that's correct. And at 40 degrees north latitude and 40 degrees south latitude, we have the what? Yes, we have the westerlies. Very good. And the westerlies are pushing this water, the trade winds are pushing this water across in a circular motion, which we call a gyre. But now let's back up. Here's where the new term comes in. Remember we said the trade winds are pushing this water across along the equator, and then when it smacks into this continent here, it changes direction. Well, there's a special term for that. It's called Continental Deflection. It's being deflected. You know, if somebody ever throws a ball at your face, you throw your hand up to keep from getting hit in the face. Well, that's what the continent's doing. The water's going along here, and it bounces off and goes up and circles on around. So we have our gyre. It is so very, very important to remember that this gyre, that these surface currents, that they are moving warm water from the equator up to colder parts of the earth, and they're bringing cool water from the cold areas down to the warm areas. And so you bring this cool water down to the equator, it gets warmed up as it's pushed across the globe, and it gets warmed up, goes up, cools off, comes down, gets warmed up, and so we have a never-ending process that keeps the climate of our planet adjusted and is a tremendous aid in helping the sailors and just everything move across the ocean. Okay? So surface currents are currents caused on the surface of the ocean by the wind. Surface currents are caused by the wind. And we have the Coriolis Effect, which is a circular motion caused by the Earth's rotation. We have gyres, which are caused by the surface winds and the Coriolis Effect, and these gyres are circulating endlessly out in the ocean.